Hey, so welcome back, and this is another daily LeetCode problem. So today it's called number of subsequences that satisfy the given sum condition, and it's an easy level problem. And so what you're given here is a matrix, and you can see that the number of columns and the number of rows are always the same. So it'll always be like 3 by 3 or 4 by 4. They'll always, it'll be symmetrical. And so what you want to do is just take the sum of the kind of, I guess they call it primary and secondary diagonal. I usually think of it as like right and left. But all that you want to remember though is after, when you do this, you don't want to count, say if it's say if there's a middle one, which I think is when you get an odd number of like number of rows or odd number of columns, you'll have one that kind of gets caught in the middle twice here. And so you only want to count it once. And you can see that by 1 plus 5, 9, 3, 7 here. Like you only count that number 5 once in this calculation. Otherwise, you would have gotten 30. And then for this one, because these aren't actually an even number, or an odd number, sorry, you won't actually have that because no number gets, cut through that diagonal twice. Okay, so to do this, it's quite popular trick here, and you have to do this a lot for these kind of beginner array problems where you want to take like the diagonal of something. And so to do that, all that you have to do is just say for every number in a particular range, and we just want to go through the length of the matrix. Let's say we store a result in a variable called result or response. And all you do is you just add to the result the number at the index of I. And the reason this works is that this index here is like column 0, row 0. And then this index in the middle is at column 1, row 1. And then this index at the number 9 here is 2 and 2. And so that's just that logic there, where for every iteration, you just want it to be the exact same number or row number as the column number. Okay? And so that accounts for the primary diagonal. Now for the secondary diagonal, it's very similar. You can do the exact same thing, except now what you want is for every iteration of the row number, you want to subtract it by the number of rows. And so what that looks like is you take the length of this matrix, and then you minus the current column that you're on, or the current row that you're on, minus 1. And the reason this works is that row, let's start at row 0 in this case. You want this one, so then you just do 3 minus 0 minus 1, which is 2, because it's index, or it's column number 2, since it's 0 based. And then for this row, row 1, you do 3 minus 1 minus 1, which is then, the result is 1, and that's at column 1 here. Okay, and so that kind of explains why we do this logic here. All right, and so what you can actually do is you don't actually need 2 for loops here. I kind of like it because it helps simplify it for me, but you can also just do it like this. Since, I'm gonna try that again. So put that down there, put that here, remove that, and we can actually just take this and add this as well. Oh, there. Great, and so with that, all that remains is that extra case that I talked about of what if, since this number in the middle can get repeated twice, if it's an odd number of rows or columns here. And so you just have to say, okay, if the length of this matrix is odd, and you can tell if it's odd if the mod of 2 is equal to 1, then we know it's odd. So check if it's odd, if it has an odd length, let's say. Great. And so all that you have to do is then say, okay, the result is itself minus the matrix at in the middle. And what that is just the length of the matrix. And you just do an integer division by 2. Great. And so that will give you the number in the middle. And you just want to subtract it once so that you don't have any duplicates of that number. And then finally, you just want to return the result. Looks good. And success. So for time and space complexity for this, it's just O of n time, since we just have one for loop here, and it just iterates through the diagonal like once, and then everything else is just like constant time. And then for space complexity, it's just O of 1, so it's constant space as well, because we're not using any extra data structures here. All that we're using is the matrix that's provided to us. So yeah, I hope that helped, and good luck with the rest of your algorithms. Thanks for watching.